Day 1, 8 o'clock in the morning. It's about 61 degrees in the temperature. And as you can see, the humidity is about maybe 68%. That's the relative humidity. I'm going to be tracking that along with the rest of this experiment. Why, hello there, friends. Thanks for clicking on this video. Yes, it's early in the morning and coffee's still steaming. I hope you will take a moment or two to give this video a thumbs up, and if you find the content to your liking, please share it with your bestest of buds. Before I get into the entire context of what I want to read to you, my friend Robert sent me some information from a handbook that he recently acquired. It's an Improvised Munitions Handbook by the United States Military. And in this Improvised Munitions Handbook is a section on making black powder. And I'd like to read that to you because there's some things in here that really piqued my attention. And one of the things actually relates to something that I've been doing with my black powder in the drying process that I didn't realize I was kind of like doing the same thing. Let me explain here for a moment. Before I received this from Robert, a video on my recommended list had come up from a younger feller making homemade black powder, and he was screening it, and are all familiar with the process of screening. But he also, I think if I remember right, boiled some water, put the ingredients in, and don't remember if he used alcohol or the CIA method with the acetone, but for the context of what I'm talking about, that's irrelevant. When he got it all screened, he set it outside in the sun to dry. And at some point, he made the comment that he does not like leaving his gunpowder overnight once it's dried, because we all should recognize that potassium nitrate is hygroscopic. It draws moisture into the potassium nitrate. So he said when he sets it out in the sun and it's dry, that's when he goes ahead and puts it in a sealed container. And actually, guys, and I've showed before on this channel, and I've talked about drying my pucks. I put them on the dashboard of my truck, and I even at one point I took my little heat gun or my temperature gun and I pointed it at the pucks, and I got a reading of like 164 degrees. While those pucks are that hot, that's when I break them up and I corn them, grind them up, and I size them. Because in my mind, that's when the puck is the driest. And I've never given, honestly guys, I've never given any consideration of letting the pucks dry for 3 or 4 days to make sure that they're dry before I size them. Because the very nature of potassium nitrate is that it draws moisture. And that's why in the context of everything that I'm going to do over the course of several days, I'm going to go to the temperature gauge and show what the temperature is and what the relative humidity is, and then I'm going to weigh the puck. So what I've kind of been doing inadvertently, this is what this young fellow said, and this is what I'm going to read in this manual. Now, one other thing, it's kind of a little side point, but I did do this. There's another young fella out there that says that he doesn't use dextrin as a binding agent because he allows the sulfur to act as the binding agent, because under those pressures the sulfur plasticizes. And that's one reason why I got away from the 75-15-10 and went from 75-15-11. Now bear in mind what I just said, because that's going to play into what I'm going to read in just a moment, okay? So what I did is I took a little bit of sulfur, put it in my pucking die, and I compressed it underneath that 12-ton jack. And this is what I got. It's very hard. Very solid. So when that young fella mentioned that sulfur acts as the binding agent, I don't disagree with that, because this is what the sulfur did. Okay? It does act as a binder. Okay? So, take a few moments, and I'm going to read from the Improvised Munitions Handbook, United States of America, War Office, and there's the little symbol on the bottom. Improvised black powder, Section 1. Black powder can be prepared in a simple, safe manner. It may be used as blasting or gunpowder. Material required: potassium nitrate, granulated, 3 cups. Now pay attention to the amounts they're using, because those that are a stickler for 75, 15, 10, how do you get that precise weight when you're just doing things by cups? Let that sink in. Granulated, 3 cups. Wood charcoal, powdered, 2 cups. Sulfur, powdered, a 1/2 cup. Now in that sulfur, that 1/2 cup, is it 10 grams, 11 grams? You know, how many grams are you dealing with when you're dealing things in 3 cups? Yeah, you may have a measurable container that has, you know, a 1 cup, 2 cup, 3 cup line, but within that line, how much are you really putting in terms of grams? Alcohol, 5 pints, and in parentheses, whiskey, rubbing alcohol. Now, I have a problem with this, because if you're in a wartime situation, why in the hell would you use your whiskey to make gunpowder? Use the rubbing alcohol, etc. Water, 3 cups. Heat source, 2 buckets, each 2 gallon in capacity, at least one of which is heat resistant, either metal or ceramic. Flat window screening, at least 1 foot square, large wooden stick, cloth, at least 2 feet square. Did I read? Yeah, large wooden stick cloth. That doesn't make sense, but hey, this is the government trying to explain this. What else would you expect, right? So here's the procedure. Place alcohol in one of the buckets. Place potassium nitrate, charcoal, and sulfur in the heat-resistant bucket. Add 1 cup water and mix thoroughly with wooden stick until all ingredients are dissolved. Add the remaining water, which should be 2 cups at this point, to the mixture. Place the bucket on a heat source and stir until small bubbles begin to form. The bottom of the page, there's a caution: do not boil the mixture. Be sure all mixture stays wet. Okay, and then they have a little diagram right there, and it reads, number 4, remove bucket from heat, pour mixture into alcohol while stirring vigorously. Let alcohol mixture stand for 5 minutes. Strain mixture through cloth to obtain black powder. Discard the liquid. Wrap cloth around the powder and squeeze to remove all excess liquids. Now I have to interject something here, because over the years that I've been demonstrating making black powder, I've received, I don't want to say so much a criticism, but a thought process that says that little bit of moisture that's, you know, being squeezed out the bottom of your pucking die, well, you're losing potassium nitrate. But how does that equate into what we're reading right here? When you're squeezing off all that mixture, all that alcohol, all that water, are you not in essence getting rid of some of that potassium nitrate along with? Number 6, place screening over a dry bucket. Place workable amount of damped powder on screen and granulate by rubbing solid through the screen. And once again, they have a picture demonstrating that. Note, if granulated particles appear to stick together and change shape, recombine the entire batch of powder and repeat steps 5 and 6. Step number 7. Spread granulated black powder on flat, dry surface so that layer about a ½ inch thick is formed. Allow to dry. Use radiator or direct sunlight. This should be dried as soon as possible, preferably within 1 hour. The longer the drying period, pay attention, the longer the drying period, the less effective the black powder is. I'm going to read the caution. Remove from heat as soon as granules are dry. Black powder is now ready to use. Isn't it interesting that the military handbook says the less effective the powder will be? The longer your drying period, the less effective the powder is going to be. So for those that like drying their gunpowder for days on end, are you really doing your powder a disservice? Well, that's what I'm going to test right here, just simply because we know the nature of potassium nitrate is hygroscopic. So what I'm going to do is I'm going to step away from the camera, and I have some powder here that I've been saving over time. I was really going to save most of this for in that little .31 caliber Remington pocket pistol that I have. But this particular gunpowder is, juniper aspen mix. And in my process, when I get down to the very end and I have just a little bit of powder left that I can't make a full complete puck, it ends up in this jar. And in time, I can either use it for my .31 caliber or use it as a priming powder for my flintlock, use it to pack in my homemade percussion caps, or if I get enough of it, make 10, 12 more pucks and grind it up and put it in my containers to be used as a 3F. So I'm going to step away from the camera. I'm going to make a sizable puck. I'm not going to make a thin one. I want to make it kind of thick so that I can get a good weight. And what I'll do is I'll come back in here and I'll weigh it on my RCBS scale, record that weight, and then I'll set it in on the dashboard of my truck for a few hours. When the sun gets to it, it's still early in the morning, usually about 10 o'clock is when that sun starts hitting my dashboard. And I do leave my windows all rolled up when I go through this process. And then periodically, I'll take it out and I'll weigh it. And when I can recognize that it's stopped losing weight, then that should be a real strong indicator that the gunpowder is as dry as it's going to be under those conditions in the dashboard of my truck. I'll come in and weigh it, record the weight, and then I'm going to let it sit here in my shop overnight. And then in the morning, I'll come in, 8 o'clock, we'll take a look at the temperature once again and what the relative humidity is, weigh it and see if it's gained any moisture just by sitting out. So let me get part of this accomplished and I'll be right back at you in a moment. Did you all miss me? It's only been about 3 minutes. Alright, there's the puck, 1 inch. I've already measured the thickness, it's 5/16. So now I'm going to level off my scale and get a weight. Okay, as you can see, the scale's level to the table. Let's drop it on into the pan and see what we got. Let's go right up to 100, 150, 140, probably. Well, it's between 140 and 150 grams here. Let me, it's going to take 2 hands for me to do this, so let me fine tune this and I'll get right back at you. So there we are, zeroed out, and I've got 143.7 grains. And also to let you know, for the context of this experiment, I used my 50% water, 50% acetone, and I went a lot heavier than what I would normally do in making a puck, just so that I can get a weight and I can see just how much moisture that the sun is going to take out of this puck while drying. So I'm going to go sit this on the dashboard of my truck as soon as the sun hits it, give it a few hours, and just see. And so if anybody's curious, at this moment in my shop, it's about 65 degrees and about 62% relative humidity. Let the experiment begin. 3 hours later, 156 degrees. I'm going to go put that on the scale right now, and we should be able to see if it's lost any moisture. I have not adjusted the scale from the previous weighing, and you can see for yourselves it's already lost quite a bit of weight. So I'm going to go ahead, set the camera down, and figure out what it is, and I'll get right back at you. So there's the 0, and now I'm at the 130 mark, and it's 1.3, so it's 131.3. So I'm going to go stick this back in the dashboard of my truck for a couple more hours and check the weight at that time. So another hour has elapsed. 153.8, 156.5. So we've got a good number, 156.5. Now let's go weigh it. So there it is, leveled. Let me get this right. It's 130, 1, 2, 3, point, I don't know how well you can see that, but it's 0.8. So we've lost a little bit more in that additional hour. So I'm going to go ahead and put this back out in the vehicle and see how much more we're going to lose. 159 degrees. Okay, it's 2 o'clock in the afternoon. Puck's been drying for 5 hours now. Inside my shop you can see it's about 90, about 88 degrees, 40% relative humidity. So I'm going to go get a temperature off that puck, bring it in and weigh it, and we'll see what it is after 5 hours. Now keep in mind, I do not typically make my pucks this thick. Usually they're about half this thickness, and usually 4 or 5 hours in the sun on my dashboard, the pucks are pretty dry at that point. But for the context of this video and this experiment, I made this puck a little bit thicker, and as I mentioned earlier, I put a lot more moisture into the pucking of it than what I normally do also. So let me go get a temperature off of that, and we'll put it on the scale. 148. Just to let you know, it is starting to cloud up, so this hasn't been sitting in the sun completely all this time because the clouds are rolling in. But let me go get a weight on this thing. So from the previous weight, it's lost a little bit more. Let me adjust the scale and we'll see what it is. So there's the scale, balanced out. We're still at 130 and 0.6. So it's lost 0.2 grains in the past hour. So we're getting down to what's going to be the final weight. I'm going to give it another hour and come out and weigh it again, and we'll record what it is, and just so that everybody can once again see, relative humidity right now is 40%. 136.4. Probably not going to get any hotter today because the clouds are rolling in for the monsoon. So let's get in and get a weight on this and probably just decide for the day it'll be done. Well, as you can tell, it hasn't lost all that much more weight, but I do have to confess something here. It's actually an hour and a half later. I kind of took a little nap. Damn, it's pretty bad when naps get in the way of progress. But I'm going to just do a little bit of adjustment here, see what it is, and probably call it for the day. Just simply because I don't think it's going to lose that much more weight. But let's see what we got for a final weight. And then I'm going to leave it out here overnight and see if it's gained any weight from collecting any moisture. Well, there it is. Zeroed out. And the little dial gauge here is now at 0.4. So I've got 130.4. It's lost another 0.2 grains in the past hour and a half. Confession time. I kind of took a little nap, so it's been an hour and a half. It's actually 3:30 in the afternoon now. You can tell in my shop it's almost 100 degrees and 34% relative humidity. I really don't think it's going to lose that much more weight as far as this puck is concerned. So I'm going to leave it as it is. We have what I'm going to determine to be the final number, 130.2 grains. I'm going to leave it in the shop for the rest of the day and come in and check in on it in the morning and see if it has gained any moisture from being in my shop, because I about guarantee you come tomorrow morning you're going to have a whole lot more humidity in here, especially since it's starting to cloud up for the monsoon. As we can look across the night skies, the humidity has gone up in this area, and it's supposed to be like this for the rest of the evening. But let's take a look at the temperature gauge, the relative humidity, and we'll look at the scale and see if it's gained anything or lost anything from sitting in my shop here with about 100 degrees up until this point. So you can see it's 7:37. It's 80 degrees in the shop right now, and relative humidity has really increased. 46%. So she's jumping up. Now I will tell you, I've already made a little bit of an adjustment. I had to re-zero the scale because sitting in here from about 3:30, I think it was, until now, the puck has actually lost another grain. I'm at 0.3 right now. So the finishing temperature, or the finishing weight for this day, is 130.3. Okay, we'll see you in the morning. So as you can see, it's 10 minutes to 7, following morning. 60 degrees inside the shop here. And I'll tell you, it's a little warmer in here because I just checked my outside gauge and it's 52. And you can see what the relative humidity is. And overnight, the puck has not gained any weight from any moisture or anything like that that would be in the air. It's still at 130.3 grains. So I'm going to leave it here for a few days and check it and see periodically if it's gaining any weight, and I will let you know. So here it is, the 26th, 7:19 in the morning. We're still at 0. 130.3. So it's been a few days now, but what I find interesting about this morning, it's 60 degrees, but look at the relative humidity. It rained off and on all night long. So you would think, at least I would think, that this piece of gunpowder that's pucked, and since we're all convinced that potassium nitrate draws moisture out of the air, that this would have been a little heavier this morning. And it's not. So I'm beginning to think and wondering if when your gunpowder is pucked and that sulfur is plasticized, as some people like to use that wording, if that helps protect the potassium nitrate from gaining any of that humidity or moisture that's in the air. I'm going to leave this for the rest of the day, check it again tomorrow morning, and if there's no change, what I'm going to do is I'm going to bust it up into smaller pieces as I can, and then I'm going to put it back in the scale, weigh it, and then observe what that does for the next few days. Because right now I'm beginning to think that when the U.S. military said, you know, use that gunpowder or store it within the first hour, otherwise it degrades, I'm wondering if that only pertains to the screening method and not the pucking method. We'll find out. Okay, 7 o'clock p.m., the 26th of August, and I can tell you the lowest the relative humidity got today was about 60%. And as you can see, it's gone back up to 78%, and there's been no change in my scale. So what I'm going to do is let it set overnight, check it in the morning, and then I'm going to go to break it up, weigh it, and we'll see if the potassium nitrate's going to gain any moisture if the pieces are smaller. But as of right now, it's been, what, 4 days sitting out here with relatively high humidity, and there's no change in the weight of this puck. Interesting. So here we are, August 27th, 7:35 in the morning. This is interesting. Look at the relative humidity. It's at 90%. And the scale, still at 0. 130.3. And that puck, the potassium nitrate, in all these days and all these different humidities that I've showed you, friends, has not gained any moisture. And it hasn't lost any either. So I'm going to give it to the rest of the day, because if there's going to be any chance of this puck gaining any weight because of drawing in moisture, we're going to see it today, in my opinion. Stay tuned for what's coming up next. As you can see, it's August 27th, 5:59, 6 o'clock is the end of the day. The scale hasn't moved any at all. And this morning we went from 90% relative humidity to right now it is, between 50 and 60%. And it is sprinkling outside right now. So I'm going to end this portion right here, because it's pretty obvious to me that in the puck form, like it is, and in the amount of time I've let it set here with varying temperatures and relative humidity, it has not gained any weight, which would indicate to me it has not gained any moisture, even though potassium nitrate is hygroscopic. So what I'm going to do, and or before I continue on, it hasn't lost any more weight neither. So when I pulled it out of my car after several hours of drying on the dashboard, it was dry. So what I'm going to do now is I'm going to take a few moments, break up this puck, and then I'm going to put all the pieces back in the scale, balance it out, write down that number, and observe it for the next few days and see if there's any changes. This video is getting long enough as it is already, so unless something significant really happens, I won't be recording anything until the very end of it. So there's the scale, pretty much balanced. It is now at 128.6, and the relative humidity has gone up just a little bit. So, and it's all broken up. You can see there's varying sizes, and why there's a little bit of a weight difference, because when I was breaking it up with the hammer, a few pieces flew out and went onto the floor. That typically happens. So I'm going to leave it like this, observe it in the morning. Unless there's some significant change over the next few days, I'm just going to leave it as is and observe it, and I'll conclude everything within a few days if there's any significant change. Stay tuned. In editing this, I realized that a short clip that I had recorded had come up missing. Once I got that puck broken up, I had a weight of 128.6. A little while later, I had to readjust the scale to 128.0, so it lost 0.6 grains after I broke it up. I was beginning to wonder, even though I suggested the puck was dry, it hadn't gained any weight and it hadn't lost any weight, but once I broke it up, you could see on the scale that it had lost some moisture. So I'm beginning to wonder, with that puck being all together, if it retained some of that moisture. That would be the only explanation I would have for it losing 0.6 grains once I broke it up and it had a chance for some of that moisture to escape. So I'm going to leave it at this, continue on. Well, there you have it, 8:22 in the morning, August 30th, 2024. The scale has not moved since the initial adjustment from 128.6 to 128.0, and as you can see, relative humidity is 86%. Temperature is 61 degrees perhaps. And last night in my rain gauge, I got 0.3 of an inch. Over the past several days, there's been quite a bit of moisture in the air, and this gunpowder right here has not gained any weight whatsoever. In fact, it's lost some from the initial breaking up. But what I'm going to do is I'm going to wait till the end of the day, and then I'll turn the camera on myself and I'll give you what I feel is my takeaway in this little experiment. Well, it's the end of the day, August 30th, 4:30 in the afternoon, and as you can see, there's no change in the scale from the 128 grains. Okay, you can see what the temperature is in my shop right now and the relative humidity as compared to what it was this morning. So y'all may be curious as to what my final takeaway is. What have I learned from doing this little experiment. Well, before I get to that, I just want to reference the beginning of the video, reading what I read from this manual, and how they suggest when you screen it, as soon as it's dried, preferably within an hour of that drying time, get it into your container. Because we all do recognize that potassium nitrate is hygroscopic. Now, what I've done in the course of this video is I've taken the puck and I've weighed it after I put a lot more moisture in it than what I normally typically do. Put it in the scale. Once everything balanced off, there virtually wasn't any change until I broke the puck up. Now granted, a few little pieces flew on the floor, but I gave you that measurement, and then the next day I'd lost, what, 0.6 grains. That indicates to me perhaps there was still moisture locked inside of that puck. Now, my typical procedure in any of this is when I take it off the dashboard of my truck, and or in the winter time when I use the dehydrator, I tend to break the pucks up when they're still warm. When I do that, am I allowing any trapped moisture to escape? You can decide that for yourself. But I will tell you what I have done on 2 occasions, and I haven't done it all the time, and I don't know why I did this. I just did it for perhaps shits and giggles. But on 2 occasions, once I've got my 100 grams already broken up and into the container that it's going to stay in, I've taken it out of that container and I've laid it on one of my flat trays and I put it back on the dashboard of my truck for maybe an hour, hour and a half. I have no reason as to why I did that. I just did it. Am I going to do that from here on out? Perhaps. Perhaps, because what this has showed me, that even though it's drying on my dashboard, if I let it set in an environment like this for a few days, I'm not letting that moisture, apparently, to escape. So that's one thing that I may just change from here on out consistently, is once I get it sized and put into the container, once all of the work is done, then I may just empty out the container on a flat tray and just let it sit in the dashboard of my truck for a couple hours, just in case. So that's my takeaway from this. And here again, it's 104 degrees in here right now with 30 to 36% relative humidity. I'm pretty confident this gunpowder right now is pretty dry. So anyhow, I guess that's all I really want to say. This is my takeaway from what I've done. But what would an experiment in gunpowder be, or black powder, if I didn't put it on a block of wood and light it off? Let me go do that. I'm dealing with a total weight of 128 grains. So I've got to put a little bit here, burn it, and then burn the rest of it. I really don't want to burn all 128 grains right now all at once. So let's see what happens. And these are bigger chunks, as you can tell. Woo! So that's what that block looks like, with bigger chunks. But where's all the smoky residue? Okay, and again, looking at it, all of the potassium nitrate is very, very fine little pieces. So I'm going to clean this board up, clean it up, and then we'll do another burn test. Okay guys, I got to admit there's still a lot of gunpowder right there. But like all good things, it must soon come to an end. Woo! So there's the block. after that large amount of gunpowder. Yeah, it's black and it's dirty, but you would expect that from, you know, a gunpowder that you're using charcoal as the source of your fuel. But once again, the potassium nitrate is very, very fine. Very fine. So I hope you've all appreciated this. I know I've learned quite a bit. Just kind of an afterthought here. I know I've watched several videos of people making homemade black powder. And one thing that I have noticed is, in my opinion, it just seems like some people are burning their coal source, charcoal, maybe a little bit too long. I know when I had watched the video from Hoffman Reproductions, when he talked about at what point Swiss stops charring their wood and they get that really, really light to dark, I should say dark brown to almost black color, that's when they stop the charring process. Now I know I've seen guys, you know, talk about throwing their can in the fireplace overnight. In the morning it's done and everything crumbles by hand. I don't do that anymore. Like I said, ever since Hoffman Reproductions released that information. So what I do is I just let my wood char until the color of the smoke goes from that bluish color to dark gray. I shut it down, let it cool down, and then I go to breaking it up. And then whatever is left, I put it back in the can and I repeat that process. So my charcoal is not, in my opinion, overcooked per se. And maybe that's why I'm getting a little bit of different results than some of the other fellers. I don't know. I'm just throwing it out there because I know in time someone's going to ask about my charring process. And I also, as you've seen over the course of time, I also burn it in a controlled fire with a propane source, and I take it and I burn it, you know, like on the bottom for an hour, then I turn it on its side, burn it for an hour, turn it again, then turn it on its top, so that I'm trying to get a more even and consistent burn with my charcoal. You know, maybe that's something you guys might want to consider, because I tend to think, like when I first started making gunpowder, that's what I did. I felt like I was overcharring it compared to when the fella from Hoffman Reproductions made that comment. And you can go back on this channel to the gunpowder I made with the basswood, because it was at that point that I started paying real close attention to the charring process of my woods. So anyhow, friends, thanks for watching. I hope you can take away something of value with this. If not, then I had fun doing it anyways, because I learned something from it. I learned something from this that I will probably change the way I do things when it comes to that drying process. Once I get everything, you know, sized and grained, not grained, but granulated, like in the 2 to 3F, then I'm going to put it back on the pan and just let it dry. Now, for the time being, I do have a lot of those little silica packets in all of my black powder cans, just for that very specific reason, to prevent moisture from getting to the black powder. So anyhow, friends, thanks for watching, and I hope everybody will be safe. And if you're making black powder, think twice about what you're doing, because this stuff does go boom. Bye.